And as always, we begin with our world plate tectonic map. And unfortunately, we're kind of in the corner here in Southeast Asia. So it's kind of hard to tell. But essentially, we have on one side, we have the orange plate colliding with the green plate. But then on the other side, the red plate is then colliding with the green plate. So here we have two convergent plate boundaries, very important, that help to define the region physically. What I've done here is I used a red line to showcase the convergent plate boundary between the Indo-Australian plate, so that orange plate I was showing you beforehand, colliding with, coming from the north, the Eurasian landmass, so mainland Southeast Asia and also Borneo and the Malay Peninsula and Sumatra. So essentially you have this collision. If you notice, these arrows are sort of going in opposite directions as they collide with each other along that red line. We also have convergence on the other side of Southeast Asia, showcased with that orange line. And so once again, the Himalayas are essentially plowing into the Eurasian landmass, and what's doing is kind of forcing Southeast Asia kind of to go a little bit to the south. And so then on the other side, the Filipino plates then colliding with the Eurasian plate, forming right there along the side of the archipelago of the Philippines. And thus, subsequently, where we have convergent plate boundaries, we also have a lot of earthquakes. So this is an area part of what we call the Pacific Ring of Fire. This area of convergence that we see throughout much of the Pacific, kind of on the outer edge of the Pacific. And so in Southeast Asia, on both the convergent plate boundaries I mentioned, on the Indo-Australian plate convergent plate boundary and the Filipino plate convergent boundary, we see a lot of earthquakes. So that's our first. So we can expect all throughout where we see convergent plate boundaries, we should expect to find potentials for volcanoes. And most certainly we do. So if we go to the other side of Southeast Asia from Sumatra, we see the Philippines where the Filipino plate's colliding with the Eurasian plate. What do you know? We've had historical examples of volcanoes. One being the Mount Pinatubo eruption that happened before a lot of you were probably even born, June 1991. This was a massive, massive volcanic eruption. So what we had is we had, billions of tons of stuff was magma, and stuff was essentially brought to the surface and then obviously exposed in the form of ash and dust into the atmosphere. Further, we've got a lot of sulfur dioxide, about 20 million tons that was produced from this natural example of pollution, not human caused. We also had destruction of our ozone layer from this natural example of pollution. Further, because of all this, the aerosols and all the particulates in the air and the atmosphere just doesn't disappear. It essentially, dissipates and filters off all throughout the atmosphere across the world. Essentially what that did was it caused global temperatures to go down about 1 degree Fahrenheit. So essentially what that is, the aerosols, all that stuff in the atmosphere was blocking incoming solar radiation from coming and hitting the surface, and so thus it actually created cooling. So now on our map that showcases where we have convergent plate boundaries in Southeast Asia, the star indicates the origins or where the Mount Pinatubo eruption occurred. However, these are local situations. A local natural hazard then becomes a more regional natural hazard because of the wind patterns in the particular time. And June actually brought a lot of that ash and soot onto mainland Asia, Southeast Asia, but also as far as Borneo in the Malay Peninsula. So much that this image here is actually from across the South China Sea. That ash was brought over to the Malay Peninsula where this image was taken. Another natural hazard, besides volcanoes and earthquakes, it's an outcome of convergent plate boundaries, is a tsunami. And there was one that happened in 2004 that killed 250,000 people. That is a huge amount of deaths. If you think about that, that's about as many people go to the Indy 500 every year who died in this one natural hazard, this one natural disaster event that occurred just the day after Christmas. So you had a lot of Europeans, even some Americans, Australians, who were vacationing during this time in Southeast Asia, especially to get away from the winter that we would find in the Northern Hemisphere. So that also added to a lot of the death tolls. You had a lot of people who were along coastlines hanging out on beaches when this huge tidal wave, this huge wave, essentially came and surged onto the shoreline. And just to understand the magnitude, this isn't just a big wave that kind of hit the shoreline. To show how far inland this huge wave